All right, so good afternoon, everybody. We are group 6A, the plant monitor group. All right, so let's start by meeting my team members to you all. So first is Karan Patel. He did mainly the front end part. Second is Zijilin, who mainly did the connections from ESP32 to the front end. And that's me. I took care of the back end in C++. Okay. So basically what's the purpose of making this app? So most of the farmers still use traditional methods for growing their crops, and they have zero idea about the weather and technology, and that is why their crops fail. On the other hand, there is an inexperienced farmer who has a knowledge of weather and technology, but has no experience in the soil, and that is why his crops fail too. So as a solution to both of these problems, we decided to create an app which connects both of these problems. So we took ideal requirements of certain plants, and from the sensor readings we get from the actual soil we have, we compare it with the ideal requirements and provide personalized care suggestions to the individuals. We also give current weather stats to through our app, so he can see what's the current temperature and humidity required for the plant. We use Atsign, the very important part for encryption of data through ESP32. So this is how the cycle of my app goes. First, we get the actual sensor reading from the soil, which is encrypted using keys. Then we get the ideal requirements of the soil from the sensors. Then we compare those actual readings with ideal requirements and give suggestions on what changes should be made in the soil. We also get the current weather, so the farmer can see what is the current weather, the temperature, humidity, and everything. So that's the cycle of my plan. All right, so let's move to the hardware. This is my ESP32 breadboards and all the sensors. The first you can see is the water sensor. So water sensor is used to check the level of water through which the plants get the water, like the tanks and stuff in the farming. The second is the light sensor. What's the light, the sun rays the plant is getting. So light sensor is used for that. The third is the moisture sensor to check the moisture in the soil. And the third is the steam sensor, which is like to check the humidity and the air. So that's my ESP32 and the sensors I have used. So now let's move to the demo. First, my friend ZG will explain the ESP32 side, and then we'll quickly move to the live demo. ZG, over to you.
Okay, so how the C++ code work is by putting the ESP32 with the key file. We encrypt it with the key file, and then for the floater app, we also encrypt it with the key file, and then we put them on the S server. So we put it on the server, then we can receive the data from the ESP32 to the floater with the data protection from the SI company. And how it works is after we connect the ESP32 and the floater app, we read the value by using the signal pin on the sensor. We connect them to the ESP32 with the motherboard, the breadboard, and then we can get the data of each sensor, and then we can fetch the data into a auto variable, and then we send it to the floater app. Next.
Yep.
So that's how it works. We put those data into the become an key, and then we put them to the outprint. So we use the Wi-Fi to put them into something AK, and then we just send it to the floater app. Next.
All right, so that was from the ESP32 side. This is from the Flutter app side. Yeah, CG. So this is where we accept the add signs in the Flutter app. Yeah, I'm sorry, over to you, Karan.
So I get the idea by doing this from Ryan. That's a good idea to like make a key file between the data between two assign, because when I use the original method from the tutorial, it did not work because it cannot find assign. By using this method, I am able to successful to transfer the data from the ESP32 and to the Flutter app. Next.
Okay, now let's move to the live demo. So when we click on onboard, as ZG explained, we get the current Atsign which we provided by AdKey, and we build a secured encrypted bridge via AdKey servers, as ZG explained, and here we get to the homepage. At homepage we have list of all the plants. These are currently we are fetching from an array. We have here a list of plant name and its details. If we open a plant, we get the ideal details which a plant required, like a light value, temperature, humidity, moisture, and stuff. And here we have current weather stats, and on the sensor reading, we are currently getting reading from the sensors. Yeah, so the light value is this, it's very low right now. If I put a flash on it, so if I put a flashlight on it, we can get like higher light value. These are all the readings we are getting from sensor. We have a water sensor in a small tank to get the data from the water sensor. So here are all the readings. If we click on generate result, it will give us a feedback based on the ideal readings and the sensor readings. It will match it and give us the feedback. Yeah, so the light sensor, yeah, the ideal light value is 100%, which we are currently getting at 0. Yeah, which we are currently getting at 3.46. So there is very low light, so we're getting feedback as it's too cloudy to plant. Same goes for the water level, moisture level, and sim sensor as well. So yeah, that's for the live demo.
So this is how we have like calculated the humidity, moisture, and etc., light, everything. So like I checked the highest value in all the sensors, and then I made a formula to see what's the data is returning from the sensor. So it's human readable or human understandable. So that's how we created the formulas. I checked the sensors individually and the highest consequences, and that's how I got the data. All right, so that was our demo. That's it. And after like 3 months of creating this app, this is the lessons we have learned. Like we got hands-on experience on ESP32, being a computer science student, having no hands-on experience on hardware. We got to know ESP32. We also created a Flutter app for the first time. That was very new, and to make connections was really challenging. Also, the time management and work divisions was really tiresome. The sensors connecting, sometimes the sensors are not working, sometimes the ESP is not working, so that was challenging too. But we came through all these challenges and we made an app. So yeah, that's it from our side. Thank you so much. I hope you liked our presentation. Thank you.
So today we're group number 3, comprising of Nalav, Yegor, and Tasnim. we're excited to present our project on the garage door opener. And our goal is to demonstrate how this innovative system can revolutionize the way we interact with and control our garage doors, making our lives easier and more convenient, and special thanks to Atsign's privacy and encryption. Before we delve into the details of the project, let's take a look on the key topics we'll be covering today. First, we'll discuss the motivation behind our project and why we believe it is an important innovation. Next, we'll examine the requirements and safety aspects of our garage door opener, specifically focusing on the role of the Atsign. Moving on, we'll explore the graphical user interface and how it enables users to interact with our system seamlessly. And after that, we'll give you a sneak peek of our working demo to showcase the project's functionality. And finally, we'll share some of the obstacles we encountered along the way and how we overcame them to bring this project to life. Now let's discuss the wanted backstory and the motivation behind our project. Barbie was living her fabulous life in the dream house, and one day she was at work and her long-term friend Bratz came to visit. And Barbie's still stuck in traffic. She wanted to let her friend in, but she couldn't. So she figured how great it would be to have an app on her phone, which she could use to open and close the garage door without being there physically. So as you can see, the idea for the garage door opener was inspired by Barbie, who expressed the need of the remote system that would enable her to open the garage door safely, securely, and without physically being present or having to move. In today's fast-pacing world, we're constantly seeking the ways to make our lives more convenient and efficient. And our project aims to address this need by providing a reliable, easy-to-use solution that always allows users to control their garage door remotely, ensuring safety and accessibility. Let's dive deeper into the details of the project. Our garage door opener system has three main features that set it apart from traditional solutions. First of all, it is efficiently and securely locks users in using the Atsign protocol. This authentication method ensures that only authorized individuals can access and control the garage door opener, adding an extra layer of the security to the system. Secondly, our system provides real-time alerts about the status of the garage door, keeping users informed whether it's opened or closed. This feature eliminates any uncertainty and allows users to monitor their garage door from anywhere, from around the world. Lastly, our garage door opener also has a unique feature that allows users to pause or unpause the door's operation. This functionality provides users with additional control over their garage door and can be partially used in case of emergencies or unexpected situations. In today's world, cybersecurity is of utmost importance, and one of the concerns with any remote control system is the potential threat of being hacked or compromised. And as our garage door opener relies on the remote connection, it is essential to address these security concerns. I'm passing to Tasneem.
So because of the security concern, Barbie finds Atsign company on the internet. This was a solution to all her internet account problem. She could log in using the Atsign across all platforms and not being getting hacked or her data being stolen. The main benefit of using Atsign is all her information was stored once and all the application could only access it only with her permission. Most importantly, all her data is end-to-end encrypted. So now we'll go over some of our components that was given. Now that our systems are all safe and secure, these are the components that we will be working with. Our microcontroller, our ESP32, the motor that's using to open and close the door, our servo motor, and then our touch sensor that sends the signal back and forth that the door is open or closed, our LCD monitor to display, and our RE sensors that we will use to manually open or close the door. Now, this is all our parts assembled, all our hardware. So the door is set to close, which is our initial step. And then over here, we are demonstrating the RE sensor manually rotating to open the door. As we can see in the first slide, it's 20%. It eventually goes to 40 to 60 to 80 to 100. Now we will take a look at our UI and I will pass it over to Marlon.
So I'll be going over a situation where Barbie asked the devs to explain how the garage door being opened remotely won't compromise the house to the theft or burglary. As we can see in the diagram above, the ESP32 randomly generates a time frame token and updates the Atsign secondary server with the token that it's generated and it is stored in an encrypted form that only a mobile would be able to decode. The Java app reads the time frame token whenever it needs to perform an action on the mobile or an app and sends that action back to the Atsign, updates the Atsign secondary server to ESP32 to read the token. The ESP32 on a constant time frame or intervals when the action or event is being not performed will read the Atsign secondary server for any new incoming changes to the mobile or application event, and it would also update the Atsign secondary server with encryption to reflect the current state of the circuit back to the application. And the UI, on the other hand, would perform a frequent read of the keys on the Atsign to get this data synced with the circuit. Whenever an event would perform on the ESP32 would receive an event. Suppose the door was supposed to be opened, it would spin the motor and update the LCD, while if it is an event was registered to ESP32, it would update the Atsign with the following event and Java would be reflected. Before we go into the live demo, we'll go the obstacles regarding the project. First of all, the main issue was the figuring out how the LCD pins work with the ESP32. As you can see that previous image had lots of wires going up and down all over the place. Second being the rotary encoder was a task in itself because it has a specific mechanism on how it records the increment or decrement. And finally, from the back end or the hardware side, my main issue was that we made a model of a Lego door that we tried to open with the servo motor, but the motor was not strong enough to move all the mechanism. So we are currently at a situation where we have just a single Lego piece moving with the motor. As for the UI side, we had trouble deciding getting the Flutter app because of some technical issues and us being not being strong in programming and mobile app. So we settled for a Java Spring app, which has some issues in itself. Now to the live demo. Just as we are in trouble setting up the changing the front camera to the back camera. It's back. Second, it's updating the circuit. Second. Currently, on the first connection, it would have some basic keys that are being default would be set back to the default values for the event, and it would try to set the app event and keys back to default value. It would first display the LCD. It will display the door is closed on the screen, and then we'll be ready to begin or demonstrate the actual performance demo. Give just a second, please. The LCD was a
Malav, you are on mute if you are speaking.
Malak, you're on mute. I don't think they can hear us.
No, I don't think you can hear. Tasnim or Yegor, can you hear me?
Professor, are you saying something?
Right, Malav is on mute. I don't think he can hear.
Oh my God.
Oh my God.
Okay, there we go.
Okay. So I'll be going over the, sorry for the mishap, but I'll be going over the RE sensor moving the value for the motor by a certain amount. And I increase the value, the door should go back to open, and the UI also reflects the change from it will go from 4 to 5 and vice versa. And I can take it back to the and for the halt action, was I muted?
I think so.
Will perform the halt action back once. It unfortunately crashed, but we have a video recorded of it, so I hope we can.
Yes.
So this was this is the video. You can have the link, but we have shared the resources on the GitHub. Any questions?